All right, in this series of videos, we're really focusing on trying to learn the basics and make sure we know the basics of C#. In the previous video, we did something incredibly simple. We created a very basic console application. We're now going to extend that. And one of the first things I would normally cover is like how to assign things to variables. We're already doing that a little bit here. We have this var name. We ask this question, what is your name? And then we come in here and we do a console.read line. That's going to read a single line from the console, from that little window that's going to pop up. And we're going to enter our name, and then it's going to display it back to us. Let's try this. Now, sometimes it may take a few seconds for things to build and run. Sometimes they're going to be almost immediate. I'm using Visual Studio running on a VM, on a virtual machine, running in the cloud. So things probably aren't going to be as fast as they could be if you're running on your machine. One thing nice about .NET is you can run it on a variety of platforms. You can run it on Mac, Windows, Linux. This example, I'm using Visual Studio on Windows, which is probably the best platform for doing .NET development. I personally do most of my development for .NET using Writer on a Mac, and it's actually a really great experience as well. We'd have this, it pops up a little line here. It says, what is your name? It does that because of this line here in our program, console.writeLine, what is your name? Hence there, I'm going to type in Chad, press enter. Oops, I accidentally put a little quote there and said hello Chad with that quote. Put the little quote there because I'm not a wonderful typer. And we get that. And that's what this little bit of code does here. Now, there's a few interesting little nuggets here, but one of the first ones I want to cover that I think is fairly important is this notion of top-level methods or functions or statements. Here, top-level kind of statements. These are running without a main. Up until I think it was like around C#10, this wasn't possible. This is a new thing that's been added to C#. And I do think it's something you're not going to run into a lot, but if you are doing this, it's going to be like something fairly new. Most C# programs created today are probably being created this way, where we are using a top-level statements. This could have been rewritten, and up until probably C#10 or something, it would have looked like this. We would have created a class for our program. The name of that was completely arbitrary. Everybody used program though. And we would have had a static void main, a static main method that would have passed data into our program. These two are equivalent. I actually can't run this. If I try to build this and run this right now, it's going to give me an error. And anytime you see an error, it's going to say there are build errors. Would you like to continue and run the last successful build? Always say no. We want to look at those errors. We almost never want to run something, especially when there's build problems. We're just walking into a bad thing. Let's get things running first. We can't have two mains is effectively the problem. Or we could, but it won't have to be marked as partial. We shouldn't do that. I can fix this by commenting that out. Now, notice I did a quick block comment there. All editors, or almost all editors, support some notion of this. In this case, this is equivalent to going to Edit, Advanced, and toggle line comment. That's effectively what I did, line comment there, not block. I don't know why I said block, but line comment. Boom, and I put it back. I did that using a keyboard shortcut. It's good to know keyboard shortcuts, but you can use that up there as well. Again, you're going to get something like this in almost every editor. Now if I run, what is your name? I can do it again. Get hello Chad, and we're done. All right. And we can put this back. And if we do that, we can't have this. So I'm going to delete that. And we can run it again. There's your name. And it'll give us something back. That's the notion of top-level statements. It's not, again, something we're going to run into a lot, but I wanted you to be aware of it. It could affect how things are running, especially if you're running some older code. It's very important to know. It's a good start, though. All right, we'll jump into the next video. We're going to get into variables. All right, we're back. We're going to jump in and look at variables now. And we have a variable already here. We have this var name. Var is a keyword. It was added probably around 2008. So it's been around quite a while. It can mean effectively anything. People think that means things are not typed. They are. C# in general is a statically typed language. That means all types are defined by the developer writing them in the editor. There are ways to work around that in C#, but in general, C# really wants to be statically typed. Static typing, some people refer to as the first unit test. It ensures all our things will build. It's, in general, pretty nice. I think that one of the bigger reasons for it, though, it actually helps tooling a lot. Because our editor can know the type of something, it can provide us better autocompletion for that. Now, with the notion of AI-assisted programming, things like GitHub Copilot, I don't know if types are as big of a deal as they were 3 years ago or 5 years ago. Right now, I still think they're valuable, but we'll see where we're at 10 years from now if we still see types as valuable. But anyways, we have this variable here, and we have it's named name. And if I F12, it says navigate to definition, and it navigates us to type string. That is because this is a string. We could have written this string here. That would have been equivalent. Now, if we do an integer here, it will yell at us. It puts this red here because that is not assignable to an integer. If you put a var here, it will take whatever thing there and work. You'll get different philosophies on whether it should be typed or not typed. I think some people will make a strong case that everything should be typed and it makes it easier to read, easier to do code reviews on. I'm personally not a fan. I'm personally a fan of var everywhere. I think types are really useful. I think they're more useful for the editor than they are for us. I think we can often infer them and do a pretty good job inferring them. So I don't think they're of much value. Now, if you come from other languages, such as TypeScript, you may think of different things. If you're in a JavaScript world, var means something slightly different because in there, typically, if you're in a TypeScript world, you want to use let and const. You typically don't want to use var in JavaScript, but in C#, I think using var is a good idea. Now, one thing I do want to point out with variables and kind of play along here is I don't love us defining the variable really before we need it. We could have defined it here. In general, in programming, people recommend defining things at the latest point you need it, and I think that is in general good advice. So we can define this here, and we can run it, and it will behave the same. We'll get hello Chad. Now, with variables, they do kind of have implicit type. Var age equals console.readline, and we can now get our age. Now, the problem with asking for age, and we'll find that out here in a second. What is your age? We'll put that in. And then, actually, I'm going to put this up here, and then we do console, your age is this. So let's run this and see what happens. What's your name? Chad. What is your age? 47. You're 47 years old. That's interesting. And it all worked and seemed to work great, and the world's all wonderful. We were able to drop that in there and show it. What's the problem? Well, we typically don't want, or we wouldn't want to store age as a string, and that is what this is returning. So if I F12 here, it's a string. We'd probably want that to be a number, right? And there's a variety of ways we can get this to be a number. All of them have different trade-offs. I'm going to choose a fairly easy one right now. Maybe not the best one, but we're going to choose one. It's giving us a little warning there. Could be null. We're not going to worry about that. We can actually have other problems. Actually, int.parse. Now if I F12 this, I did want to show this. It's now going to give us an int. So it's now an integer. So let's run this and see what happens. What is your name? Chad. What is your age? Let's do 47. You're 47 years old. Now it appears that everything worked just the same, but now we actually have age as a number. So now we could do console dot write line. You are I don't want to get into that. That's showing you are, and we're going to do age times 7 in dog years. If we had left that as a string, we couldn't have done that. Now, if we're in the JavaScript language, we maybe could have done some stuff there, and it would have gave us an answer, but not a good one. But because we have this as an integer, we can actually do this. Let's see how old I am in dog years. So we're going to run this again. And I'm 329 years old in dog years. Getting up there if I was a dog. So that's, interesting. It's a number. We can do things with it. We have those number-related things we, could do. Also, though, that int.parse could be a problem for us, right? It's assuming it's an integer. There's name, Chad. Almost anything can be a string, but what happens if I say my age is... Type it out. Is it going to work? Boom. No. Because that input string was not the correct format for an integer, it's going to blow up. And it's going to get a system.format exception. Now, a system format exception, you're going to run into those, but this is because we're doing a parse. And this is going to do a hard insert into that. Now, we could have done something, and we're going to play with some variables to kind of work around this problem. And we're going to give an error to the user. There's a variety of ways we could have done this. One is we could have put everything inside of a try catch. Let's see what happens now. What is your name? Chad. Old you. 47. And it blew up and it says, please enter a valid number. What happened? Well, because this wasn't a string, it threw an exception, but that exception was now caught by this try catch. Try catches are kind of advanced, but I wanted to show this here. You know, you're going to run into them. It's important to know how to do this. And again, I want you playing along, kind of building effectively the same application I'm building here. Now, for this next piece, we are going to go through and get rid of this try catch. Try catch is a way to solve this problem. In general, I think we're best to avoid using exception handling in our programs as much as we can. We're going to have to do it a few places, but let's keep it to a few places. So I want us to try, and we're going to do we're going to read the age as a string, and then we're going to try and then parse it. So how are we going to do that? Be thinking about this. Maybe even pause the video. How are you going to parse that? All right, we're going to throw it into age str and parse it. Now this isn't going to be wonderful because it's going to do the exact same thing. So what are we going to do here? Let's try it and see what happens. Well, we know it's not going to do the same, so I guess I don't feel like I need to try it. We need to look at parsing this in a different way. There's two ways we could do this that I can think of really easily, but I really quick want to show int dot try parse. Actually, this actually we can just do an int, and we do this method try parse, and it'll output the result in an age variable. This out statement here is something we will get into during the course of some of these videos, not the immediate ones, but it's an important concept. It's an output parameter to this method. It's going to actually output the variable that's coming in. By default, things are passed by value. And this one we're choosing to pass with this out, so it's going to be outputted on the result. So just right now, be thinking we're going to actually update that variable. That's what that out is meaning for us. Now we can do this. Let's run and see what happens for us. What is your name? What is your age? 47. That worked just as before. Let's run it one more time, but this time I want to type in Chad, and we'll just type Chad for my age. Doesn't make any sense. It says you are 0 years old, and you're 0 years in dog years. That's interesting. Why is that? Well, because try parse, kind of as the name states, is trying to parse it. Now, our goal isn't to get into control flow right now. We're going to do that in another video. But just be aware that this method is returning a Boolean, and we could be checking the status of that Boolean to see, is it returning the value we want? For right now, we're more focused on variables and just kind of getting a little bit assigned to how that kind of works. Now, for right now, we're going to live with this little bit of weird, but we are going to move on to, we're actually going to create, we're doing this math right here. I want to change this to be var dog years equals this, and then dog years. And why did I do that? Well, the other one is actually totally fine and totally acceptable, but I just want to show we can take an expression, age times 7, and store it in a variable dog years. And this age times 7 will result in an int because we are using ints. That all make sense? Hopefully it does. You can get and do this. Hopefully following along. Now, one of the things I wanted to look at, or at least bring up in some of the math related stuff, what if we divide by 7? What if we change our equation for dog years? Save this, run it. Change what a dog year is. Chad, we'll do 47, and you're 6 in dog years. Math becomes interesting. We start doing division with this, and we're storing it in integer. The reason I say that is because it will fundamentally convert that and do some rounding there, right? Let's do this again. We still get 6 in dog years. We could make things into a decimal or a double and get a different value. I mean, we could actually get a better value, or I guess more accurate. What if we put double in front of age? What if we cast it to a double, a floating point number? We now get a floating point number as our result. We started with the floating point number, did division on it, and got a floating point number. That's at 6.7. Very important when anytime you're doing math, you must know what type of numbers you're working with. If you don't, it's going to be hard to know what type of results you're getting. Now that result, 6.7 and a bunch of stuff after, it's not wonderful. We maybe want to do some cleaning up if we were to display that. But at this point now we got more accuracy. And if I look at this var here and do an F12 on it, it's now smart enough to know we're going to a double. So again, even though var doesn't really change, it's the same word. If I get rid of this, we're going to have an integer. Now, for your assignment, is I want you to ask the person for their height in using a console read line. Ask someone for their height, and then take that height and just output it back to the console. That's all I want you to do for right now. Take in their height, output it to the console. All right? And then we'll jump into our next video.